Hey guys, hope today finds you well. This is Preston with the DLASC, here to talk about another logarithm rule. This time we're going to talk about the quotient rule, and we're going to go about this. If you watched my other two videos, we're going to take the exact same approach. And the first thing that I'm going to do is go ahead and list the relationship between logs and exponents so that we have something to reference here. Okay. And this is going to be, hopefully you know this by heart by now, should be log base a of b. If log base a of b is equal to c, then it's definitely true that a to the c is equal to b. Okay, so we got that. That's important. Move that off to the side. Now we're going to talk about what the quotient rule is. So the quotient rule is really similar to the product rule, and if you know the product rule, it's relatively intuitive. Okay, and what that rule is log base a of b over d is equal to log base a of b minus log base a of d. Okay, and so just like we had done before, we're going to take this guy, pick him apart, and try to explore, see if we can make sense of why this works. Okay, so just like with our product rule, we're going to need two separate expressions. And I'm just going to go ahead and use the exact same expressions that I had used before for the product rule, so that we can stay consistent. And if I recall correctly, that expression was log base a of d is equal to e. Now, again, we know that if that is true, then it must also be true that a to the e is equal to d. Okay, so now we have our relationships written out, we have our rule written out, and we want to go ahead and try to prove that rule. And I'm going to start the exact same way that I started the other two. I'm going to start with a to the c is equal to b. Okay, and again, the form is b over d. That's what the argument in the exponent is. So what I want to do is divide both sides by d, keeping in mind that b is equal to a to the c. If I divide b by d, I must also divide a to the c by d, okay? Because we want to keep this relationship true. So I'm going to have a to the c over d is equal to b over d, okay? Cool. Now, notice that a to the e is equal to d, right? So if that is true, which it is, then what I want to do is substitute, because those both have the same base. I think I'm going to be able to simplify it a little bit. So I'm going to have a to the c over a to the e is equal to b over d. Okay, cool. Now we can use an exponent rule, which is that x to the a over x to the b is equal to x to the a minus b, right? Or actually, rather, probably would be better to show it as x over a, oops, looks like a 9, that bugs me. Make sure this is an a, there we go. X to the a over x to the b is equal to x to the a times, it's another 9, oh my goodness, x to the a times x to the negative b, okay? And then that in turn is equal to a x to the a minus b, right? Okay, hopefully that makes sense to you. If it doesn't, then you might want to go and review some of your exponent rules I might end up making a video on that here pretty soon and proofing that one so that you have some intuition. But for now, we just need to keep that in mind because we're about to use it. Here we have a to the c over a to the e. That means that a to the c times a to the negative e is equal to b over d. And again, we can pull those dudes together. We have a to the c minus e is equal to b over d. And then now I have another expression. Okay, if you watch my other two videos, hopefully you can already see exactly what I'm about to do. So note the relationship between logs and exponents, okay? If they're inverses of each other and we know how they're laid out, then that means this right here means that the log base A of b over d is equal to c minus e, right? Okay, and if that is true, we can see here that there's some substitutions that we can make, right? Because c is equal to log base A of b. That's my first one. Okay. And then e is equal to log base A of d. So I'm going to go ahead and substitute that in. Log base A of d. And there we go. I think we proved it. So again, the original expression is this dude right here. That's what we started with. That's the rule. Okay, we started with the relationships between logs and exponents. We manipulated it, right? And we were able to use arbitrary variables to show that this is true for any constants, right? So formally, therefore, log base A of b over d, some constants, is equal to log base A of b minus log base A of d. And keep this in mind while you are simplifying expressions in algebra or calculus or whatever. These rules come in really good handy, so make use of them.